Hi everyone, welcome to the CryptoSense webinar on building a crypto-agile organization. So as usual, we'll be looking to do about 20-25 minutes of material here. Please do ask questions in the chat or in the Q&A as we go. There are some members of the CryptoSense team on the panel who will take questions also as we go along. Otherwise, I'll try and get to some of them at the end. So let's get right into it. Just to start to introduce myself for those of you who don't know me. So I'm the CEO and founder of CryptoSense. I have a technical background. So I used to work as a researcher in applied cryptography, in particular in academic institutions in Germany, in Italy, and in Scotland before coming to France to work for INRIA. That's the National Research Centre for Computing Science. And I was a postdoc for about 10 years before I founded the company. And so what I always have been about is trying to figure out how to make it possible to make it that everyone can use cryptography securely. And that's really the mission of CryptoSense. So it's enable all of our customers to protect their most sensitive data by democratizing access to securely deployed cryptography. Okay, so that's enough about me. So what about the subject for today? So we're going to talk about crypto-agility. So crypto-agility, there's a lot of definitions out there. We dug through a few to come up with this one, mostly uses material from the NIST recent publications. Crypto-agility is the ability to support rapid adaptations of cryptographic primitives and algorithms without making significant changes to the system's infrastructure and without exposure to unacceptable business continuity risks. So it's all about being able to smoothly change from one way of doing encryption or signature or whatever it is to another one, without a chance of encountering horrible bugs, basically. So things going wrong in our applications or maybe going wrong somewhere down the line from our applications in other points of the infrastructure that cause these business continuity risks. So why do we care about being crypto-agile? Well, one reason is that in the past, we have had to change crypto algorithms. And so some examples of that are changing from the MD5 hash algorithm, first of all, to SHA-1, and then having to change away from SHA-1 to the SHA-2 family. Anyone who worked through that period will know that was a lot of heavy lifting, a lot of difficult problems to solve. And we're going to have to do that again at least once to move from the asymmetric cryptography we use today to quantum resistant asymmetric cryptography. And so we know that we're going to have to do this at least once, but the chances are with these new post-quantum algorithms, we might need to change several times because they are immature with respect to their cryptanalysis. And so most organizations are trying to get to a crypto-agile state rather than just trying to make one migration. There are other immediate benefits to becoming crypto-agile. So, for example, it gives us a pathway to modernizing our cryptography, adopting things like crypto as a service or adopting cloud cryptography. We'll talk about it a bit later. It gives us a way to streamline compliance reporting. So if we have this visibility and this knowledge and this management capacity on our cryptography, we can also tell other people about that, like auditors, internal and external. And it also allows us to reduce the risk of cryptography failures. So part of this agility is just identifying where we have old legacy or insecure cryptographic constructions and being able to smoothly move those to new secure ones, even before we think about things like post-quantum cryptography. So there's a lot of good reasons why we might want to be crypto-agile. So how do we get to being crypto-agile, and how do we do that in a way that we can reap these immediate benefits? So in today's webinar, we're going to put forward our 5-step approach to this that's been built up on the ground with our customers. I'm going to explain what are the principles of the approach, and then we're going to just go quickly through these 5 steps. So we won't have time in the webinar to go really into a huge amount of detail of each of these, but at the end of the webinar, we're going to be releasing a white paper on the subject of getting your organization crypto-agile, which really includes a deep dive on all of these subjects. And so everybody attending the webinar will get that immediately afterwards. So what are these 5 steps? So first of all, we're going to talk about crypto inventory. We're going to talk about how we categorize the risks and give ownership for different areas of agility to different parts of our organization. And then we're going to look through 3 different types of areas where we might want to make adjustments to get this crypto agility. So first of all, the architecture that we're going to have adopted for new applications or applications that we're already modernizing, getting crypto agility into our CI/CD pipelines, and I'll explain why that's key a bit later. And then we're going to deal with the difficult stuff, so third-party or legacy applications that are not so easy to change the cryptography in. So the main principles of our approach are first that the inventory is really the cornerstone of this. So it's the quality of the visibility and the inventory that I have on all of my cryptography that really governs whether my agility will be successful or not, whether I can make those changes without getting those significant business continuity risks. And that's really what this is all about. And the nice side effect of that is by building the kind of inventory that gives me the agility that I need, so that deep inventory that allows me to avoid these bad continuity risks, that will also give me the other benefits that we're looking for. So that's really the kind of core principle. If you don't go away with anything else at all, is that the inventory is the cornerstone of agility. Second is that the main agility engine is the DevSecOps process. So the point of this is that your organization is already, almost certainly, moving towards or already has adopted a kind of DevOps set of working practices. So converging the development process with the processes needed to actually put an application into operation, check that it's working efficiently and performing well. And DevSecOps is the same, except that we're helping our developers to take responsibility for security as well. So since we're already doing this to enable agility, which is really what DevOps practices are about, they're about enabling agility, then that's where we should work to enable crypto agility. It doesn't make sense to try and build another agility engine. So work where there is already agility enablement going on, and then we get things like the automated testing and so on that we need to make sure that our agility is effective. Finally, clear ownership is required. So think about creating a cryptography center of excellence. So think about selecting a cross-function team who actually has responsibility for crypto inventory. And we've seen that that makes a lot of difference in the organizations we've worked with as to how successful the project is. So first, let's talk a bit more about inventory. So we're going to do inventory first, typically in a crypto agility project, because it's going to help us to understand the problem, understand where we are, how agile is our organization already, how much of the cryptography in my inventory was already documented and I knew about, and how much do I find that we didn't know about before. That gives us an idea of the state that we're in. We're going to have to keep this ability to keep all the cryptography visible as a permanent capacity of our organization if we want to have agility. So it's not enough to do a one-off inventory, right? So we can't just do it one time and then say, okay, fine, we're now agile in the future, because when we need to change our algorithms, well, perhaps all of our applications have changed slightly, and then we do get those business continuity risks. So data that we can't decrypt in one place that we've encrypted in another, or whatever it is. So we need to be very careful to put in place an agility process rather than, and get the inventory to be part of that, rather than just doing a one-off inventory and assuming it's to be the same. And we need to make sure that all of the use cases for the inventory are addressed. So we have a little cheat sheet on cryptography inventory. It gives you some basic principles and a full white paper, but just as a sort of summary. So a good cryptography inventory is what we call three-dimensional. So it covers both the objects, so that's things like keys and certificates. It covers the operations, so that's things like the algorithm and the mode that we use to do something. And it covers the call sites. So where in the application did that get called from? Did it get called from a third-party library? Was it invoked directly from the business logic? Was it some part of the application framework? And I need those three dimensions. And the reason that I need those is because I need to be able to calculate cryptographic dependencies. So cryptographic dependencies are something that NIST defines, Safecode defines. There's a bunch of definitions out there, but essentially it's understanding where would there be consequences in other parts of the system if I were to change the cryptography here. So if I'm using a certificate in one place and then verifying in another, or if I'm encrypting with a key and then decrypting the data elsewhere, or if I change a third-party library and that third-party library is being used somewhere else, I need to know about these dependencies in order to be able to make those changes without getting those business continuity risks. So a good inventory will enable me to calculate those cryptographic dependencies, whereas a bad inventory will just have me an isolated list of, for example, algorithms and no sort of connection between them about how that data flows. So a good inventory has to be automated. So this is for the reason that I said that we need to make this a process that keeps up to date. We need to always know where all our cryptography is, so that when we need to quickly make changes, we don't need to repeat the entire inventory exercise, which would be the case if we did it manually. Manual inventory is really a Herculean task that is bound to end up with a whole lot of imprecisions. And probably by the time you get to the end, you're going to have to start again because things would have changed. So we need to be looking at automation as much as we can for this inventory. We need to think about the use case of the inventory. So there's no point building an inventory just to pass a single audit or to just get ready for post-quantum, evaluate our quantum risk, because otherwise we're going to find that those other use cases come up anyway. So we're bound to get some compliance need around our cryptography. And eventually we are going to need to do that post-quantum migration. So it makes sense to just build one inventory that meets all of those use cases. So that we can be sure that we can always be able to report for compliance or modernize our cryptography using this one same inventory, and we keep all of our effort there. Finally, we need to make sure that the inventory is built for remediation. So what does that mean? That means that our inventory contains enough information to easily calculate what we need to change. So that's another reason why it needs to be three-dimensional. We need to know what line of code made the call and what key did it use, as well as what algorithm did it use. That allows us to give enough detail to either our operations team to change certificates or our development team to change lines of code to make that remediation, so that either just moving to a correct piece of cryptography or in the future making that migration. We need to make sure that's built into the inventory. We don't just want a report card of cryptography saying there are some bad things here. We need to be able to direct exactly where the problem is and suggest what the remediation is. So as I said, we've got a whole white paper specifically on the inventory topic, and I invite you to download that and take a look. Crypto risk is an interesting point as a use case for inventory. So in 2021, you might be aware that OWASP moved cryptographic failures to #2 in their top 10. So the OWASP top 10, if you're not familiar with it, is a list of common application vulnerabilities seen in web applications. That's been around for a long time now. Previously, cryptographic failures was not identified exactly like this. It was called sensitive data leakage or something like that. And that's because things have changed since the OWASP top 10 started. The common reason now is that we are failing in our cryptography. That's how this sensitive information is getting leaked. That's become more common than just writing sensitive information in clear, though of course that does still happen, unfortunately. And so OWASP identify a whole bunch of things that go wrong with cryptography that you can look for. A good inventory should be enough to allow you to check all of those things, right? So the inventory should be detailed enough for you to give you the details and operations that you can pick up all of those cases in the OWASP cryptographic failure category. And that's going to be a huge benefit immediately from the inventory. And if you keep that inventory up to date by automating that process, that gives you a way to measure and track improvements in your crypto risk. So have we fixed these issues over time? Have we got fewer issues in our applications over time? And that can be really useful for building confidence in the AppSec program. And if you design it well, it will also take care of compliance reporting. So you might even have a OWASP top 10 compliance requirement that requires you to show that you've looked for and eliminated these kinds of issues. So about ownership. So the second part is looking for risks and delegating ownership. So ultimately, when we want to change cryptography, there's going to have to be buy-in from a lot of parts of the organization. So obviously that's going to include application development, who we're going to ask to use cryptography in a different way. It's almost certainly going to involve IT operations, because there will be configuration changes to make in infrastructure, as well in operational requirements around applications, perhaps in key management, certificate management, which might fall under your operations team as well. Vendor management, so we're going to have to start changing the way that we require our vendors to use cryptography, and the things we're going to buy and use. We need our CRO perhaps to sign off on this, to understand why it is that we need to invest this effort to make this cryptographic change. So it can be useful to have a team of people identified to take care of this. In particular, cryptography is still, unfortunately, widely misunderstood, and it is a rather technical subject. And so it can be helpful to designate a team which includes at least some people with some cryptographic experience. They don't need to have a PhD in cryptography, but perhaps they've worked with vendors before, they've understood the issues, got some experience on the ground with PKI, things like this. Associate them with a cross-functional team across those areas of the organization, and define them as the cryptography center of excellence. And so this is there's a whole set of Gartner materials you can get on this, a free infographic about the great advances of cryptography center of excellence, for example. And the point is that these people can do more than just work on your agility for you. Identifying this set of people can be really helpful for a whole lot of other business initiatives around adopting new cryptography, for example, new privacy preserving primitives like homomorphic encryption and multi-party computation. Can be really helpful if you've got a center of excellence in your organization who can work on these things. So consider doing that. And it's these people who are going to ultimately do the risk assessment. So they're going to work out how fast do we need to move to quantum, where have I got the most quantum risk, Do I need to make a change from one algorithm to another, even ahead of quantum for some particular reason? It's great to have a set of people whose job it is specifically to take care of that kind of thing. And then about where we actually do this agility. So as I said, most organizations that we speak to, at CryptoSense at least, are somewhere on a transformation to DevOps practices. And this is motivated by agility. So agility, not just crypto agility, but agility in the large, making our products, getting them to market faster, making them adjust to our customer needs faster, taking on competition faster, all that good stuff. And so it makes sense for our crypto agility to leverage these efforts and not try and create some kind of operational level of agility that's separate. And that's because this agility in DevOps implies a whole lot of useful things, like, for example, automated testing and really fast ways to work out that the changes that we're making are not going to have an operational impact on the application. And so DevSecOps is a continuation of this, where we enable developers also to take on security responsibilities. And in practice, that normally makes for a couple of things. So one of them is making best practices available. So this will be things like writing a policy about what kind of cryptography we want our developers to use and where we want them to get it from, so which libraries. Perhaps we're going to mandate particular libraries that are Crypto-Agile, so common libraries like even the Java JCE, for example, is defined in an abstract way, which is quite easy to change algorithms in, whereas some libraries are really hard-coded around the algorithms, which makes them much harder to change. And we may even want to introduce abstract cryptography libraries. So this is quite common these days for an organization to have a simple to use library that can be used for encryption at rest, for example, and then all developers can just self-serve that without worrying about things like algorithms or agility behind. It might be linked to cloud crypto or dedicated cryptography as a service. So it's all about giving the developers the ability to self-serve that stuff. And then we put in place controls, because we want to make sure that these things really are used. It's not enough just to say, well, here's a best practice library, good luck. We want to make sure that before we deploy an application, it really is using those best practices that we defined, and we're not putting at risk any sensitive data. And so we need to embark those controls in there. And this all makes total sense inside a DevSecOps pipeline. So if we're moving to DevSecOps, the chances are that we're leveraging a technology like continuous integration. So we're going to make it possible to, for any change of code, rebuild the code and rerun automated tests. And so this is a great place to do cryptography scanning. So we can take advantage of existing functional tests that we're doing to add tracing of cryptographic operations. So why do we want to do tracing and not just static scanning? So static scanning is fine, particularly for looking for bad patterns around cryptography, obvious uses of bad algorithms and so on. But it's not much good for taking inventory, and it's no good for dynamic issues with cryptography. So things like reuses of IVs are really hard to impossible to figure out from static scanning. So if we really want to get that visibility that we were looking for in our inventory checklist, so the ability to cover that whole OWASP category, to report compliance, to be ready for agility and calculate dependencies, we really want to trace the running application to see all of the third-party library cryptography it uses, and to see how that cryptography actually runs in practice, what really gets called. So this is a great place to do that when we've got tests already running in CI. We can also statically scan the repository and container images that we might build along the delivery pipeline for cryptography artifacts. That's another great way to get visibility into what's being used. And what we really want to do in CI is integrate the results into a developer workflow. This is what's called shift left sometimes. So the idea is, rather than the developer commits something in, it creates some cryptography results. The results go to a cryptography team. Then at some point they send them all the way back down in an email to a developer to say to fix something. What we want is that our tooling integrates, for example, with an issue tracker that our developers are using, and immediately gives them the information they need to fix any issues, and maybe links to where our policy is, maybe a way to contact the cryptography center of excellence if they need to, if there's some sort of exception that needs to be registered. So that way the remediations are really self-serve. So this is how we can really scale crypto agility in the organization. And it's that unique workflow that we get from the CI pipeline in a DevSecOps context that really allows us to do that. So the result is that we're always up to date. The CCOE can always see what's going on, and if necessary, push out changes to policy and watch them be the uptake of that policy change go over time. So we can start by warning people they need to change something, and then maybe red warning them, and then eventually maybe even blocking the build if it hasn't changed. And so over time, we can really monitor that. So crypto agility really becomes a process we can manage now from the CCOE rather than just something magic that we sort of hope is going to happen. So unfortunately, in reality, some high-value applications might never get to the CI pipeline, and they might have very little test coverage for whatever reason. So what can we do there? Well, we can still do cryptography inventory. So for example, we can trace an application in a UAT environment or even in production with the right kind of tracing to see what it actually does when real data goes through there. And so we can still really figure out what kind of cryptographic operations are happening. Of course, that's only one step, right? So we've got the inventory, but now we want to make a change for an agility reason, either just to fix something or to change to a new algorithm. So if we can't support code changes and recompilation, and unfortunately it is the case that there are applications like this floating around that actually have value, there are various other ways that we can make cryptographic changes. Here at CryptoSense, for example, for certain legacy Java applications, we have repurposed our tracing agents to rewrite bytecode to call different cryptography from what the application originally wanted to call. So you can talk to us about that, but there are other technologies that are similar around. There are other ways to sort of monkey patch your application to get it to do different things. And of course, you don't really want to do this, right? It's much better to update the software than update the security software, as Phil Venables recently said. So if we can get that application into CI, that's definitely a much better path. But sometimes, unfortunately, that might not happen. And at least we need to have a plan for what we would do if we did have to upgrade that cryptography quickly. And then there are some really nasty legacy cases where we might not even be able to trace or scan or even static scan. Perhaps it's some really old technology, I know some mainframe application written in COBOL or something, and we really don't know what's going on in there. So there are various ideas floating around about what to do with these applications if we really need to keep them, we can't work with them, and we need to, for example, get them ready for post-quantum cryptography. And essentially, these ideas involve wrapping up the application inside an environment which we have to keep secure. So we know that the cryptography inside is no longer considered secure. And so we need to wrap it up, put a proxy on the outside that can support crypto agility, so it can support post-quantum when we need to and so on, and use that to communicate to the outside world and just sort of admit the risk of having to keep that internal environment secure. So that's fine, but of course, there are various ways this can go wrong. If there's application level cryptography in there, for example, if the application is signing documents with an old algorithm that won't be post-quantum resistant, then just the fact that the results are carried on a secure proxy won't actually help. That somebody could still forge a document in the future once there's a big quantum computer around. So we need to be really careful there. One way that we can get improved visibility that we've seen work quite well is by exploiting dependencies. So what does that mean? So it means I don't know what cryptography is going on inside this application because it's opaque. It's written in some language we can't really look at anymore. We can't compile it. Or maybe it's a piece of infrastructure, so we can't even get access to it. But often that piece will be talking to another piece that maybe I do have more visibility on, like a piece of client software that talks to that piece of infrastructure. And by tracing the client and seeing what that end of the communication is, I can figure out what kind of cryptography is going on the other end, on the end that I can't get tracing on. So that can be really helpful. So if I can see, for example, verification of a certain kind of certificate going on the client, then I can guess that it's the server that's doing the signature is using that exact algorithm. So that can be really useful. Okay, so in summary, we've worked through a little summary of our 5-step process for getting to crypto agility. So as I said, right after the webinar, we're going to be sharing a new white paper on how to achieve crypto agility that basically goes through these steps, but in much more detail. So there's a lot of little lessons in there from the ground that we've come across that can really help you map out a program for doing this. And we've seen that by following this process, we don't just get ready for post-quantum cryptography migration, which is a big thing we should be thinking about, but there's a whole lot of other immediate benefits around cryptography moderation, modernization, and ways to reduce cryptographic risk and streamline our compliance reporting and so on. So I'm really happy to share that white paper with you afterwards. Also really happy to take any questions that you've got right now. And thanks very much for your attention and for joining us here at CryptoSense. Just right, so just one question here about the link between remediation and agility. So is crypto remediation crypto agility? So I don't think it's interesting. The terminology of what crypto agility means is it's not a kind of tightly defined term. We've seen different people have different understandings about this on the ground. But yeah, agility, so is the ability to change cryptography without exposure to business risk. So for me, that includes fixing just errors in cryptography that we have right now. It isn't just about changing algorithms either. It could be about changing details in the random number generation, the way that we manage IVs, the way that we apply modes data. All of that is changes to cryptography that we want to do in a way that doesn't cause business risk. So for me, that is crypto agility. So when we're remediating crypto vulnerabilities, we are in fact exercising a little bit of crypto agility, in my opinion. Yes, there's one question about managing cryptography from vendors. So yeah, this is clearly a big part of crypto agility for most organizations. Most organizations don't control already every single piece of cryptography they use. They're mostly procuring solutions, and the crypto agility will involve getting those suppliers to change the cryptography that they're using inside. So in our white paper, we actually go into this a little bit more. So part of your crypto agility program has to be a vendor management program, and you'll want to be engaging with your vendors. And there are a bunch of sort of sample questions there about things you might want to engage with them about to understand their stance on agility, and be able to work with them in a way that they can help you, but be a partner for you to get to the crypto agile state that you want to get to. Yeah, we've got one more question about standards. So meeting cryptography standards. So crypto agility is something that is being pushed hard by the standards organizations, like NIST, for example. They all suggest that you procure agile solutions, but it isn't really something that is yet in, for example, the FIPS standard. So FIPS 140 doesn't require that your solution is crypto-agile. It says a whole bunch of things about the security of the cryptography and what things you can use. But there's not really a strict requirement for crypto agility in there. But my feeling is this is likely to change. So I think that certifying a solution as crypto agile is something that we're going to see very soon. People will be able to say, this is a product and it's certifiably crypto agile, so that it can become quantum resistant, or it can change its cryptography as you need. And this is going to happen in the very near future. Okay, that looks like all we've got for Q&A today. Thanks very much for joining us, everyone. And you'll be getting a link to the white paper plus the recording afterwards. Feel free to share it around within your organization. And I hope to see you again here soon for another webinar here at Crypto Sense. Thanks a lot.